Okay, so far we've talked about hydraulic transient theory and how certain components and devices are used. And at this point, we're going to talk about how to actually construct a model from external data. So sometimes you're not going to just manually lay out the elements like you did in the workshop. You may have that data in some type of data source, like a shapefile or a spreadsheet or something like that, and you may need to construct that model based on that data. So just to overview, a very high-level overview, a hydraulic model is a piece of software plus some data. So you enter that data once and you can use it many times. So once you have that model constructed and all that data entered, you can use it in the future. You could make small changes to it as things are changing. Fix data errors once. So the whole idea for a model and GIS integration here. So you use the data entered by someone else, and sometimes that data may not always be perfectly accurate, and we have a lot of different tools where you can go in there and fix up that data before you go and attempt to perform a hydraulic transient and attempt to trust some of the data that you're seeing. So the idea is that you build that model, you fix up any data entry issues or any artifacts of the import process. You get all that fixed once, and then you have a hydraulic model that you can use in the future. So some of the different types of external data sources, there's lots of different ones, and these are all supported in some form as far as importing into Hammer. So a lot of times you might have a DXF file, a CAD drawing, maybe you have a WaterCAD model, WaterGems model, maybe you have some shape files, a geodatabase, or maybe it's just a spreadsheet with some XY coordinates and pipe diameters and things like that. Data sources take a lot of different forms. Hammer can use all of those in some form. So this is the basics of how it works. You have some source file, whatever it may be, and you have some target file, which is your GEMS data store is a bit of an old term there. It's basically your Hammer hydraulic model. So what happens to go from one to another? Well, you have to spend some time to get it, and the devil is in the details there, what you have to do to convert that data into a model. And that's where ModelBuilder comes in. So here's an example showing a GIS. The GIS has a much different view of the world than the model. They both have points and lines, but we need a way to convert those point features to model elements, which we can then do things like skeletonizing, simplifying the model down. So an example here at the top, your GIS view, you have all these fittings and bends and hydrants and gate valves and this and that. So the middle section here is maybe the model after you build it with ModelBuilder. It has a lot of extra detail that you may not necessarily need for a transient simulation. So the last bottom diagram there is an example of that same model after you simplify it a bit. You remove some of the unnecessary detail whilst keeping it hydraulically equivalent. And we will talk about Scalabrator. That's a tool for simplifying models. That'll be the next lecture. So each table in the data source must map to one GEMS element. So what this means is that whatever you have as far as a table of data, whether it's a particular shape file, a worksheet in a spreadsheet, a database table, whatever it may be, each one of those will map to a certain element type in Hammer. So some examples here, a T is probably a pressure junction. A gate valve could be a pressure junction, maybe it's an isolation valve. Air releases could either be an air valve element if you want to include them, or maybe you would want to just omit those and import them as pressure junctions. Your pumps would be a pump node. Check valves is a question. A check valve could be the check valve node element, or maybe you want to include the check valve as a pipe. So if the check valve in your data store is more of a link, a line between 2 points, then that would be imported as a pipe. So every data table in your source file has to map to a certain element type, and that's what you do in Hammer. for ModelBuilder. So in the process of doing that, for each of those tables, you need to have a common, unique identifier, a key field that links between the source and the target. And this is usually your label. So usually you have basically a list of say it's pipes or nodes in a data source, and you need to map those to the junction element type in Hammer. Well, each one of those has to have some unique identifier. So you need to make sure that you have a column in the data source that has a unique label or ID for every single thing. So in that case, if you had a label column that had, say, 2 rows that had a label of J-1, well, that wouldn't really work, because you would bring in 2 J1s, and you wouldn't have the uniqueness there. Now the thing at the bottom of this slide here is showing that there is a function that you can choose. It's called label in less than or greater than. It's circled in red there. If you choose that, then Hammer will automatically generate unique labels. They're automatically generated labels that will basically guarantee uniqueness. So if you don't have a column that has unique labels, you can always use that. I mean, it won't have the labels that you may want, but they will be unique. And this is just another example of, on the left is your data source, and on the right is the model. So you're choosing, okay, so maybe there's a spreadsheet where you have a column that's called D, and that's diameter. You have to map those between the data source and the model. So that's another step of the model builder process, where you say, okay, this column called D, I'm mapping that to Hammer's diameter field, and the column called C, I'm mapping that to the Hayes and Williams C coefficient field. So you have to go in there and link those things together so it knows where to put the information. So when you're done, you'll end up something like this. You'll end up with a table where the information is basically copied over. So some considerations. Not all fields from the source file need to be copied. So you might have some extra data in your source file that you don't really need. Maybe you have some installation date information, and if you don't really need that, you don't have to include it. You don't have to map every single field. X and Y coordinates, those are of particular concern if you're using a DXF or a shapefile or any other data source that has native spatial information built into it, like a geodatabase is another example. Those X and Y coordinates will automatically come in, so you don't have to worry about mapping an X and Y coordinate field. It's an automatic process, and basically the model that you end up with will have the nodes in the right place and the pipes connected to them. And in most cases, like for example a shapefile, you may have bends along that pipe, and those will also be imported as bends in the right location. So if you can imagine a curved pipe, where there's 2 junctions, one at each endpoint, but the pipe has a curve to it. If your data source file is a shapefile and it has that spatial information built into it, when you import it, you'll end up with a curved looking pipe, because it will import all those little vertexes, the bends in the pipe. So also system demands may be better imported using a tool called LoadBuilder. So you can, to some degree, map demand information from various sources using ModelBuilder. It's a little bit more complicated, and you really have to have in your data source the right format where you tie specific demand data to a specific element. Most of the time, demand data usually takes the form of customer meter information or some type of geospatial information, like shapefiles of the customer element, customer meters, or in some cases you have just some area-based data, like maybe you have polygon areas of different land use types or different population types, and maybe that in one type of population the average demand is some flow value per person per area. If you have that kind of data, you really need to be using LoadBuilder. So LoadBuilder basically allows you to take spatial information like that and import loads. So for example, you might have customer meter information at specific points, like a point shapefile. So load builder could be used to take the locations of those points and find where is the the nearest model element and assign that demand to that nearest element. That's the simplest form. There's many other different ways of allocating demand spatially using load builder. Similarly, elevations, sometimes you may have that directly in your data source, and you can certainly import that and map it to the elements if you import them through ModelBuilder. But oftentimes you may have a DEM, a digital elevation model, or a TIN, a triangulated irregular network, some external file that has the contours of the land. And you can use a tool called Terrain Extractor to import that information. That will interpolate the ground elevations and automatically assign those to the junction or node elements that overlap it. A note on pipe bends. So I touched on this a little bit, but files like spreadsheets or databases, they don't really contain the bend data. You just have a start node and a stop node, so you just get a straight line. So if you're looking for more detailed information that includes bends of your pipes, you'll want to be working with geospatial information. So what are some things you really can't import with ModelBuilder? So things like composite demands, it's not impossible, but it's certainly more challenging. And by composite demand, I mean for a given junction, that junction may have multiple demands on it, and not just one single demand, like perhaps a residential demand and then a commercial demand is also represented in the same junction. It's a lot more challenging to import that because the demand information for a junction is inside what we call a collection. It's basically a list of demand data nested within that junction. So although it is possible, and we do have some information in our wiki on how to do it, it's a lot more challenging, and it's often easier to to use simplified methods or perhaps assign demand spatially using load builder. Also things like engineering libraries, color coding, those are things that really don't make sense to be imported with ModelBuilder. ModelBuilder is mainly focused on bringing in the core network data so that you have something to something laid out already, and you don't have to put a DXF as a background and start manually tracing over it with the layout tools. You can take that DXF and directly import it with ModelBuilder. So types of connectivity, explicit versus implicit. So explicit means that you are explicitly mapping the start and stop node fields. So you have to say, well, this field in my data source maps to contains the label of the start node, and this field contains the label of the stop node, and that has to be explicitly mapped. And that's done in files like spreadsheets and databases. Implicit methods, so that means things like your shape files will be using an implicit connectivity, and that means that the pipes are assigned based on spatial information, based on proximity. So the example at the bottom, so the one in the middle there, it says where there's sort of the line is not really snapped to the endpoints. So we have some options in ModelBuilder that allow you to say, well, if the pipe endpoint is within a certain number of feet of an existing point that I'm bringing in, then it's going to snap it to it and connect it automatically. So that way you don't have to, because sometimes data is not drawn perfectly and things aren't snapped together, especially things like DXF files tend to have minor imperfections. But Hammer needs to, it needs to know that connectivity. So we have some options where you can say, well, if it's a little bit off, just snap it to the endpoint. Here's some connectivity issues that may arise. So pipes without end nodes. So if you have a shapefile that kind of looks like this, the one on the top here, you might end up with the second graphic here where those pipes should have been connected, but they ended up being imported with two junctions with a gap between them. And here's another example, the third one, pipes that appear to be connected but are not. So you might think that this junction here is connecting these, but sometimes if you click on the junction and drag it away, you'll see there's actually a second junction underneath it, and they're not really connected. So when you're bringing in data through ModelBuilder, especially geospatial information, DXF files, it's really good to go in and do a thorough check to make sure that that data was imported correctly, and to clean it up a bit. And we do have quite a few different tools. There's a tool called Network Navigator included in Hammer, and that has a lot of different queries that can help you identify things in the model that may not be right, and things that may need to be cleaned up. The last example at the bottom here, pipes that cross without junctions. So should these pipes be connected, or do they really cross? So if there's not an endpoint there in the data source, Hammer's model builder will import them as two separate pipes not connected in the middle. So again, resolving the connectivity problems. So there's lots of things that you can do, and this is the tolerance field I was talking about that gives you some flexibility for snapping pipe endpoints that are within a certain tolerance. So that's in one of the very first model builder steps. And the default, I believe, is to have this unchecked. So that's something that you will pretty much always want to have checked. And I think the default tolerance is 1 foot. But depending on the quality of your data, you may need to adjust that. And here's just an example of the different steps in Model Builder. So starting on the left side, so that's your main ModelBuilder Manager that has all your different Model Builder connections. The one in the middle is showing the different tables that you can select to import and a preview of the data in it. And the screenshot on the right there shows the mapping section, where you choose the key field and you map the fields in the data source to the fields in the model. And again, Network Navigator is a really nice tool, has a lot of different queries to help you identify places that you might need to check out, things like nodes in close proximity that may need to be connected, pipe split candidates, which means you have two pipes that are crossing, or a node that's overlapping a pipe where there's no endpoint, and maybe they need to be connected. Maybe it was supposed to split that pipe. Orphan nodes, these are points that are just floating with nothing connected to them. Duplicate pipes, meaning basically two parallel pipes which you would otherwise not see visually. Disconnected elements, you can run queries to see what exactly is connected to this element, and from highlighting those you can tell where there's connectivity problems. So it's a good idea to not just import the model and just try to run it. You import the model and you spend some time making sure everything came in right. Also, some elements that you import have an orientation. So you need to specify, in most cases, like a downstream element. So for example, this is important with pumps. So a pump needs to know which direction it's pumping to. Control valves need to know where the downstream pipe is, because like a PRV will be monitoring the pressure on the downstream side, and that's an important factor. Even pipes themselves, the orientation can be a factor, especially if you have a check valve in the pipe, because the check valve will be open or closed depending on the orientation. Some further tips. So snap all pipe ends to something. That's definitely very important. If it's not snapped, then it may not be connected. Make other valve point features or isolating elements. Element labeling conventions are important. This is basically to do with the whole key field. So if you have elements that are labeled a certain way and you want to see them that way in Hammer, it's important to make sure to pick the right field as the key field. And if you need to track changes to something, you can add a prefix to the beginning of the element label, and that's done through the flex table. So if you wanted to import data from Model Builder and then add some prefix or suffix to everything, there is a tool in the flex tables that allows you to relabel. And then also tanks, pumps, valves, they should all be in their own table. So meaning if you have, for example, a spreadsheet and you have a worksheet in there, a tab that says nodes, and that includes tanks and pumps and valves all in one worksheet, that can make it difficult to import into Hammer because you're mapping a table, and in the case of a spreadsheet, it's a tab, a worksheet in your spreadsheet. You're mapping that to a specific element type. So if that worksheet represents multiple element types, then you have to introduce either manipulate your data source so that they're all in different tables, or you have to use some advanced functionality in Hammer where you can set up a SQL query, or rather a SQL where clause, to filter the data and then duplicate the tables and bring them in. It gets a little bit complicated. It can be done, but it's much easier if you set these things up ahead of time, if possible, so that each type of element is in their own layer, or their own table, so to speak.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.